My name is Anthony, and I represent team number 2, Icon. And the company we chose to explore is PACCAR Inc. Before we get into how PACCAR established themselves as a leader in the trucking industry, I feel it is important that we take a look at how they became the company they are today. In 1905, William Piggott Sr. founded Seattle Car Manufacturing Company to produce railway and logging equipment. The company later merged with the Toohey brothers of Portland to become the Pacific Car and Foundry Company, a name it retained for the next 55 years. In 1934, Paul Piggott, son of the founder, acquired a major interest in the company. Under his leadership, the company expanded its products and introduced the Carco line of power winches for use on crawler tractors in the logging industry. In 1945, the company entered into the heavy-duty truck market with the acquisition of Kenworth Motor Truck Company of Seattle. In 1958, Pacific Car and Foundry expanded their heavy-duty truck capabilities with the acquisition of Peterbilt Motor Company. Later that year, the company also acquired Dart Truck Company. Something that I found interesting was that ahead of the 1962 World's Fair, PACCAR's structural steel division fabricated the steel that was used to construct the Space Needle. Fast forward to 1960, Pacific Car and Foundry became an international truck manufacturer after the creation of Kenworth Mexicana. In 1966, Pacific Car and Foundry entered into the Australian truck market with the establishment of a Kenworth truck assembly plant in Melbourne, Australia. In 1972, the directors and shareholders agreed that Pacific Car and Foundry Company no longer reflected the company's product offerings and voted to change the company name to PACCAR Inc. To get more information on PACCAR Inc., I'm going to pass it off to Jason.
So I'm Jason of Group 2, Icon Group, and I was going to talk a little bit about PACCAR's major brands. The first of which is the Kenworth trucking brand. They have 3 production facilities, one in Renton, Washington, one in Chillicothe, Ohio, and one in St. Therese, Quebec. The one in Renton, Washington also makes the specialized trucks. So you see this picture we have here that's got 2 steer axles on this truck here. That's a truck that came from Renton, Washington. The 3 main models they make are the T680, the T880, and the new W990, which was just released a few months ago. The other major brand that PACCAR operates is Peterbilt trucks. They have 2 production facilities for the Peterbilt trucks. One's in Denton, Texas, and the other one is in St. Therese, Quebec. The 3 major trucks that they make, the most popular models, are the 579, the 389, and the 567. So something that's interesting about how PACCAR operates is Peterbilt and Kenworth actually compete with each other. They go after the same customers. When Kenworth customers come into our facility, we have to actually remove the Peterbilt logos and the Peterbilt trucks, and then the same thing when Peterbilt customers come in. Some of the other brands that PACCAR operates is DAF Trucks, which is European. They have a production facility in Eindhoven, the Netherlands. It makes trucks and engines, and they have a plant in Westerlo, Belgium that makes cabs and axles. And then they have a plant in Ponta Grossa, Brazil that makes DAF trucks for South America. So DAF trucks are primarily used all over the world except for North America. They don't really meet the North American market requirements. Some of the other ventures that PACCAR has is Dynacraft. They make powertrain and axles. They have PACCAR Winch Division. They have 2 plants in Oklahoma. In Oklahoma. One of them is in Broken Arrow, Oklahoma. The other one's in Okmulgee. They have 3 major brands that they do: is the Braden, Gearmatic, and Carco winches. Those are winches they use on tugboats and cranes and heavy-duty wreckers, real heavy-duty equipment, very heavy-duty winches. Then I want to talk a little bit about PACCAR's engine plant. So in 2007, 2008 timeframe, they built a new production facility in Columbus, Mississippi. It's 450,000 square feet. It has machining of both the cylinder head and the cylinder block, both of which are CGI, compacted graphite iron. About 260,000 square feet is dedicated to machining, and the rest of it is dedicated to assembly. And the whole thing has a Industry 4.0 design in mind. Everything is automated. All the machines talk to each other. They talk to the production systems. They provide feedback on key process variables and key information. For instance, the fuel injectors on our engine are flow bench tested at the fuel injector manufacturer, and that information is assigned to the serial number for each injector. That information is assigned to the serial number for the engine and to the ECU. The ECU takes that information and adjusts flow rates for each injector so that all 6 cylinders have the same amount of diesel fuel flow. So very complicated process, very involved. The last thing I'd like to talk about is the actual maintenance department within the PACCAR engine plant. Right now we currently have 62 people. There's over 100 CNC machine centers that we maintain and take care of on a daily basis. We have a plethora of robots. The assembly line automation is quite extensive. We have EFT, which is engine function test. It's actually a cold test of the engine that is all completely automated with robots and high-level automation. We have 5 hot test cells. Every single engine is power tested for 20 minutes at full peak load and torque, as well as programmed. The ECU is programmed at that point for the respective truck chassis that engine's going in. And then, of course, we have an automated painting process that we have to maintain that goes through and paints the engines once everything's done. We're also responsible for taking care of all the plant facilities, the chillers, air handlers, all the air compressors. We have 4 200 horsepower air compressors that keep our plant supplied and compressed air. Chip and coolant is a major maintenance obstacle. We have a 180,000 gallon central system that processes about 40,000 pounds of compacted graphite iron chips or shavings every day. That has to be maintained on a continuous basis to make sure that it keeps fresh coolant flowing to all the machining centers. And then our MRO spare parts. Right now, our facility, we currently have a little bit over $20 million worth of inventory in MRO. These are everything from ball screws and linear bearings to tables and gearboxes. Some of them are really high dollar parts that we have to catalog and keep up with and make sure that we have them when we need them. Some of the things that we do, of course, we do breakdown and reactive maintenance. When things break, we have to fix it and get it back up and going. We also do the preventative maintenance for the machines, changing the oils, doing periodic inspections. And we're here more recently, we're moving into predictive maintenance. We do FLIR audits, ultrasonic audits, oil analysis, things like that. And you see this little picture down here on the bottom. It's a picture of a ball screw and some linear bearings. It just kind of shows how it goes together. And these are kind of things these guys have to work on a daily basis. With that, I'm going to turn it over to Aaron. He's going to pick up where I left off.
Thanks, Jason. We chose to focus on PACCAR's maintenance management process. But before delving into PACCAR's process, let's briefly discuss what maintenance management is. Maintenance management is managing the control of maintenance activities. The earliest form was breakdown maintenance, which was repairing equipment after failure. The modern day approach is preventive maintenance, which is performing maintenance in order to prevent failure of equipment. The maintenance process has 10 fundamental steps. They include request, approval, plan, schedule, perform work, record data, account for cost, develop management information, update equipment history, and management control reports. Prior to technology, all of these tasks were completed using pen and paper. Fortunately for PACCAR Incorporated, others in the manufacturing industry, and those in other industries with heavy reliance on maintenance, computerized maintenance management systems, CMMS, exist to make the maintenance management process easier at each step. CMMS software allows the request, approval, and scheduling of work orders to be completed. The files are electronically submitted to improve efficiency. It not only collects data in an electronic database to help schedule time-based preventive maintenance, but it is capable of scheduling need-based predictive maintenance. PACCAR Inc. implemented the computerized maintenance management system software throughout their organization long before establishing PACCAR engines in 2010. The facility located in Mississippi began its operation using CMMS that had been previously tested at other company facilities. PACCAR gives autonomy to each part of their value chain to determine which CMMS software addresses the needs most. Another division of PACCAR Inc., PACCAR Parts, even has its own brand of CMMS named Connect that they offer to their customers to ensure the entire life cycle of assets and expenses are tracked and reported on. PACCAR Inc. places such an importance on CMMS, and maintenance management has been described as the last frontier of the manufacturing industry because reliable equipment is said to be the main factor when considering the performance and profitability of a manufacturer.
Thank you so much, Aaron. So PACCAR has been successful through many elements. The two critical success factors that I'm going to emphasize on today are in relation to the way PACCAR carries out their operational activities and all management and planning strategies. So to start with the operational CSF on the left, PACCAR takes pride in staying open and available to all customers 24/7. Aaron just elaborated on the use of CMMS, which is also a part of limited downtime and only down for maintenance when traffic is low. This prevents PACCAR from running into issues of missing customer requests and addressing all urgent needs, which aids in maintaining a positive consumer base because someone is always there to help when traffic is high. Then we do CMMS checks that allow for employees to regularly control and monitor all sales and inventory. They're also able to maintain a record of all equipment and downtime, which helps avoid revenue damage in the long run. The thorough system checks allow for PACCAR to limit costs, plan budgeting, and improve their scheduling to increase production measures. By knowing the time frame that it takes to address and solve each operational problem, PACCAR can then improve their tactics to increase efficiency and resolve similar occurrences within a shorter amount of time in the future by creating prevention measures. To move on from this one, the operational critical success factor has been a huge component in their success. Then we have the management and planning CSF on the right. From what I've learned so far, PACCAR executes amazing techniques for management and planning. They start with the detailed employee training and provide product knowledge. The knowledge that each employee receives never stops because they're continually kept up to date. Since the employees are trained in all products and equipment, then they're able to pinpoint out errors quicker and come up with solutions even faster. For example, if there's an information systems breakdown or any type of machinery failure, then that would cost PACCAR about $50,000 an hour. So in order to avoid that, materials are constantly being turned over and assessed for their necessity. Another factor that CSF involves is IT and software releases. The IT department is always making changes and updates to its system by releasing software updates. Those changes are then made to revise the CMMS system and assess its speed of performance. All of this leads to increased production because everyone on the PACCAR system is using one platform, which allows them to continually be on the same page. PACCAR has been able to reduce downtime, procure materials, and increase production through these elements of these critical success factors. That's all I have for CSF now, and I will go ahead and pass it on to Ratna Kumar.
Thank you, Hira. It was a wonderful presentation. Now I'm going to talk about PACCAR's information system infrastructure layout at a high level. As you can see, PACCAR maintenance department uses CMMS FlexNet software, and it also has IT to support the whole maintenance department IT needs. CMMS is robust, has robust analytics and business intelligence features, and it primarily eliminates information silos. It helps business to resolve at least 3,000 flags per month, which is very critical for their revenue and to meet their corporate goal of profit. Of course, it runs 24/7. IT support takes care of providing regular production support, and it also monitors maintenance activities and takes care of the upgrades of FlexNet software. As you can see below, they have primary data center and DR data center. Primary data center is nothing but production center, which contains all the servers to serve the need of CMMS software. A DR data center is primarily, you can call it as a backup center, or it is a center used as for business continuity. The data from production to DR kind of replicates instantaneously and continuously. The IT department takes care of periodic DR testing to assure recovery time objective and recovery point objective. It's recovery time objective is 4 hours and recovery point objective is less than a minute, which is really good in Packard. And IT department has 15 IT support team members and 2 IT administrators. Now let's go over the architectural overview of CMMS FlexNet software. As you can see, CMMS FlexNet is primarily built on VMware EXS server, which contains multiple nodes. That's also called vBlock. On top of this VMware, they have Windows CE 64-bit operating system and .NET application server. .NET application server serves as a web server also, which is very critical for the software development. SQL Server database is their system of records database, which is nothing but combination of tables and rows and columns, which is called structural database. On top of .NET application server and SQL Server database, there comes CMMS application layer. CMMS application layer is designed based on service-oriented architecture, and which is native BPM, and it is integrated with manufacturing and quality systems. Also, it is RFI ready. Last but not least, the application user layer, which consumes the application, and without this layer, we cannot really determine the success of the application. That's all about CMMS FlexNet overview and infrastructure of the CMMS maintenance department. Now I will hand it over to Aaron to talk about lessons learned in Packard.
Thanks, Rafna Kumar. Packard now uses Aprizio FlexNet CMMS software at their Columbus engine plant and various CMMS software at their other facilities. We recently learned that they decided to upgrade to SAP throughout their entire organization. Aprizio is suited for multiple sites, but aside from its maintenance solution, SAP also provides numerous manufacturing operations, services, and support. Packard should not become complacent after upgrading to SAP and must be sure to monitor the performance of their SAP software so that they know when to make updates or upgrade, similar to the Zadi oil case study. Now I'm going to pass it on to Rafna Kumar again.
We also learned about another interesting fact within Packard's maintenance management system. Though the system is integrated with the production and quality center, it is not a synchronous integration, it is asynchronous, and obviously it delays their metrics receiving time and decision-making time. So we suggested to explore Tableau for metrics with the real-time feed from all information systems. Thank you everyone for attending this, and I would like to say special thanks to Kenny and Packard for making this project possible. Thank you all, and thank you team. Thank you very much.